Imagine a world where your devices can see everything around them, not through a camera lens, but through the very fabric of the air itself. This isn't about facial recognition or video feeds, it's about a new kind of digital sight that works in total darkness and through solid walls. For decades, radar was the domain of massive spinning dishes on warships and air traffic control towers, but engineers have just achieved the impossible, shrinking that entire capability down to a footprint smaller than a grain of salt. This tiny marvel is the 0.24 square millimeter radar on a chip, and it's about to change how every object in your home interacts with the physical world. It's the cornerstone of a new framework called ISAC, or Integrated Sensing and Communication. To understand why this matters, we have to look at the limitations of how our devices see today. Cameras are great, but they require light, they struggle with depth, and most importantly, they raise massive privacy concerns. Current radar systems in cars are better, but they are bulky and consume significant power. To put radar into a light bulb or a smartwatch, we needed a radical rethink of radio frequency engineering. The challenge was fitting the transmitter, the receiver, and the processing logic into a space so small it could literally be lost in the palm of your hand. And the solution came from the frontier of 6G technology. In the world of 6G, the network does more than just carry data. It becomes a giant sensor. This is the heart of ISAC, the idea that the same radio waves we use to download movies can also be used to map our environment. By integrating sensing into the communication fabric, we turn every connected device into a high-resolution spatial scanner. But how do you make a sensor that small actually see with any detail? The secret lies in the way the chip generates its signal. It doesn't just send out a simple pulse. It uses a highly sophisticated piece of engineering called a Type 3 synthesizer to create a perfect radio chirp. This 0.24 millimeter squared chip is a masterpiece of sub-millimeter wave design. At these tiny scales, every micron of wire acts like an antenna, and managing interference is a nightmare that took years of simulation to solve. By operating at extremely high frequencies, the chip can detect movements as small as a human heartbeat from across a room. It's like having the sensitivity of a medical-grade sensor in a package the size of a dust mote. But the real genius isn't just the size, it's the efficiency. Most high-frequency sensors are power-hungry monsters, but this chip operates on a budget that seems to defy the laws of physics. So how do we go from a tiny piece of silicon to a full 3D map of a room? It all starts with the physics of reflection and the speed of light. This is where the engineering gets truly clever. In the next module, we're going to dive deep into the heartbeat of this chip, the Type 3 synthesizer, and see how it uses sonar-like mechanics to see the world without a single lens. Get ready to see the invisible, because the way we interact with our environment is about to be rewritten from the ground up. At the core of this tiny radar is the Type 3 synthesizer. Think of it as a high-precision conductor for radio waves. It has to generate frequencies that change incredibly fast with absolute stability. In traditional designs, generating these high-speed chirps would require a lot of space and power, but the Type 3 architecture uses a clever feedback loop to lock the frequency in nanoseconds, allowing for rapid-fire sensing. This synthesizer creates what we call a frequency-modulated continuous wave, or FMCW. It's a signal that constantly slides up and down in pitch like a slide whistle made of light. When this chirp hits an object, it bounces back, but because the signal is constantly changing its frequency, the returning echo will have a slightly different frequency than the signal currently being sent. By measuring that frequency difference, the chip can calculate exactly how far away an object is. It's a process called de-chirping, and it happens thousands of times every second inside that 0.24 millimeter squared space. This allows the chip to see with incredible resolution. It can distinguish between two objects just centimeters apart, even if they are behind a wooden door or a drywall partition. But distance is only one part of the puzzle. To create a 3D map, the chip needs to know the direction of the reflection. It does this using an array of tiny antennas that work together in a process called beamforming. By slightly delaying the signal sent to each antenna, the chip can steer the radar beam without any moving parts. It's like a lighthouse that can shine its light in any direction just by thinking about it. This creates a sonar-like mechanic where the chip pings the environment and listens for the echoes to build a high-resolution spatial map of everything in the room. The most mind-blowing part of this engineering is the power consumption. This entire radar system runs on just 9.8 milliwatts. To put that in perspective, a standard LED standby light uses about 5 times that much. Achieving this required a duty cycling strategy. The chip isn't on all the time. It wakes up, performs a lightning-fast scan in microseconds, and then goes back to sleep before you can even blink. This efficiency is what makes the technology viable for everyday objects. You don't need a massive battery or a cooling fan, you just need a tiny fraction of the power already flowing through your home. Because it doesn't use a lens, this radar sees the world in a way that is fundamentally different from a camera. It sees materials, densities, and movements, but it doesn't see colors or faces. This makes it the perfect sensor for the 6G era, a way to give our machines vision without sacrificing our privacy. It's a tool that understands the where and what without ever needing to know the who. Now that we understand the how, let's look at the where. Because once you make a sensor this small and this efficient, the world starts to look very different. Because this radar is only 0.24 square millimeters, it can be embedded into almost anything. Your bathroom mirror could track your breathing rate while you brush your teeth, alerting you to potential health issues before you even feel them. A light bulb in the hallway could detect a fall and call for help, all without ever seeing you in a way that could be hacked or leaked. It's sensing that is both powerful and invisible. This is the true promise of 6G ISAC, a world where our environment is intelligently aware of our presence and needs, responding to us in real time without us ever having to press a button. In the industrial world, these chips will be everywhere. Imagine a robotic arm that can feel a human nearby through a wall of boxes, stopping instantly to prevent an accident. No expensive laser systems required. Or smart shelves in a warehouse that know exactly how much stock is left by looking through the packaging to see the volume of the product inside. It's a level of logistics precision we've never had before. The 9.8 milliwatt power draw means these sensors can run for years on a tiny battery or even harvest energy from the very 6G radio waves they use to communicate. As we move toward a world of 6G, the line between communication and sensing will disappear. Your phone won't just be a radio, it will be a sophisticated spatial awareness tool that knows exactly where you are in 3D space. This will enable augmented reality experiences that are perfectly anchored to the real world, with no lag and no bulky headsets. Your environment becomes the interface. The engineering of the 0.24 millimeter squared radar chip is a testament to human ingenuity, a reminder that sometimes the biggest changes come in the smallest packages. We are standing at the threshold of a transparent world, a world where our machines finally understand the physical space they inhabit and where technology serves us more naturally than ever before. From medical breakthroughs to safer factories and smarter homes, the tiny radar on a chip is the silent engine of this transformation. It's a masterpiece of radio frequency design that fits on the tip of a needle. It's not just a sensor, it's a new way of seeing. And the best part? It's been right there, invisible, all along. Next time you walk into a room and the lights turn on or your phone knows exactly where you're pointing it, remember the grain of salt size miracle making it all possible. The engineering of the 0.24 millimeter squared radar is more than just a technical achievement. It's a bridge to a future where the digital and physical worlds are finally truly one. The invisible world is finally becoming visible, and the view is absolutely breathtaking.